Welcome. We're going to go through our equation of circles study guide today and make sure that you are nice and confident and prepared for our test. If you don't already know it, remember that the equation for a circle is based on our formula x minus h quantity squared plus y minus k quantity squared equals r squared. This is the equation we're going to be referring back to quite frequently throughout this study guide. So in the first one, writing out the standard equation for our circle, given a center and given a radius. With my center at 0, 0, those are the values that we're going to be using to replace the h and the k. So lucky for us, x minus 0 is just an x squared, plus then the y minus 0 is y squared, equals on that other side our r squared, 28 squared, puts us at 784. So in that question number 2, we're going to write the equation of a circle out here. Given a center, this time we are at -3, 4, and I have a diameter of 10. So make sure you convert that. We need a radius in our formula instead of a diameter, so I'm going to have to start thinking about a radius of 5. So plug these in, x minus h, so it's going to be x minus a -3, but we don't want to end up doing those doubled up signs, so we convert that instead. You're going to be thinking about x plus 3 quantity squared plus then my y minus 4 quantity squared equals my r squared, so that's 5 squared, puts us with a 25. In the next row down, we are given the point at -3, 1 on the circle, where my center is at 2, 3, to write out the equation of the circle. So we know the center, which is what we need, but we also have to know the radius. So in order to find the radius, I'm going to have to do the distance formula from the center to my point on the edge. So I'm thinking about 2 minus -3 squared plus a 3 minus 1 quantity squared. So simplifying in there, 2 minus -3 is going to have me thinking about 5 squared. Then the 3 minus 1 puts us at 2. Square that. So 5 squared is a 25, plus 2 squared is a 4. My radius in that case then is the square root of 29. Use this along with that center point so that we can write the equation. So you're now talking about x minus 2 quantity squared plus that y minus 3 quantity squared. And when I do my radius squared, that's the square root of 29 squared. The square root and the square are inverses, so they cancel each other out. We're left with that equal to 29. Now into question number 4. Again, we've got the point at 0, 6 on the circle, and my center is at -2, -1. So similarly, again, we're going to have to find the radius for this. Set up your distance formula. So -2 minus 0 quantity squared plus then that -1 minus 6 quantity squared. So we'll continue to simplify. -2 minus the 0 puts us at a -2. That'll still be squared. And my next set of parentheses, I'm looking at a -1 minus 6. That is -7 to be squared. So I'm talking about the square root of 4 plus 49. So this radius is the square root of 53. Now we put that together using my center point, center at -2, -1, and using my radius that we just found. So we're talking about x plus 2 quantity squared plus then the y plus 1 quantity squared. Again, remember, it's subtraction in the formula, so when I subtract the negative number from my center, you end up with those plus signs, equals, then square the square root of 53. So this equation is equal to 53. Now remember, for any problems that you have, like this number 3 or number 4, you can certainly check your answer in your Desmos graphing calculator. So for something like that number 3, if I type in the equation that I have written, And then the next input line, check out that point that's supposed to be on the circle, -3, 1, and look at your image results. If the point is on the circle, that should be a confidence booster that you solved that correctly. All right. On to question number 5. We're going to write the equation of a circle here, where my diameter has the endpoints at 9, -4, and -1, 0. So I have to begin here by finding the center of my circle. I do that with the midpoint. Remember then, to find the midpoint, you're going to be doing the average for each coordinate. So I'm talking about 9 plus a -1. That gets divided by 2 for my x's. Then I do the -4 plus 0 divided by 2 for my y's. So this center is then, let's see, 9 plus -1 is going to be 8 divided by 2 puts us at 4. And -4 plus 0 divided by 2 makes -2. So there we have our center. Then I'm going to need to find the radius for my circle. I'm going to use my center point and one of my endpoints, the -1, 0 here, to find that distance. So I'm thinking 4 minus -1 squared plus, and then we'll do -2 minus 0 quantity squared. So we go ahead and simplify. 4 plus 1 is 5 squared. And then in my other parentheses, that's a -2 squared. So we've got to consider the square root of 25 plus 4. Sounds like our radius value then is the square root of 29. Use these now and put it all together. I've got a center ready. I've got a radius ready. Plug that into our formula. X minus 4 quantity squared plus y plus 2 quantity squared equals, and then the square root of 29 gets squared to be 29. Number 6 wants us to identify the quadrant where the center of our circle is located. So I notice here that I have the equation set up without parentheses. So I'm going to need to complete the square in order to get this set up. First things first, I know that I don't want any coefficients on my x squared or my y squared value. So we're going to divide everybody by a coefficient there in order to clean this up. So x squared plus 2x plus y squared minus 3y equals 6. And then we'll go ahead and get these set up. So I'm going to think x squared plus 2x plus what for my first item, my first set. And then I'll also have the plus y squared minus 3y plus what for my second set. Now we know that this is all equal to 6, and of course that rule says that what I add to one side, I also have to add to the other side. So whatever I add in with my x values and whatever I add in with my y values is going to have to come along with that. So taking a look at this now, the value that I'm adding in with my x's, remember I'm going to take that b value, divide it by 2, and then we will square it. So we're talking about x plus 1 for that quantity squared. And then again, when I start talking about my y values, right, I take my b value of a -3 divided by 2, and then I square it. And so we're ready to convert that now. Right, so I've got the x, and then I've got the +1 from that division problem to complete this square. And whatever that value is, remember we're going to add it to the other side. Now for my y values, we've got the y, and then I'm dealing with this -3/2 that we have. That'll be my quantity squared. So then I have to include that as my 9/4 on the other side. Now, I don't end up actually having to worry so much about what's happening on the right side of my equation, because I'm actually only asked about the center. I can identify the center with what I have here in this information. We're talking at -1, comma +3/2. And if I make a quick sketch of that on the graph, -1 is to the left, +3/2 then goes up from the origin, and so this is going to be in quadrant 2. Now in that number 7, we're going to graph the circle given from this equation. So in here, I have to be able to identify the center using my HK values. This is at 1, -4. So I plot that point. And then I also have to be able to identify the radius. In this case, my radius is the square root of 25, also known as 5. So you're going to count that radius of 5 in 4 directions. It'll go up 1, 2, 3, 4, 5. From the center, we'll go to the right 5 points. From the center, we go down 5 points. And from the center, we go to the left 5 points. Then we use those outer 4 points now in order to sketch that circle. And obviously, some of our sketches are going to be better than others, but the 4 points and the center give us the basic idea about what we are looking for. In 8, we are asked to find the diameter of the circle. So diameter there is based on my radius. So I know that the radius is the square root of 144. That tells me that my radius is 12. I've got to double that to get my diameter, which would be 24. 9 wants us to write the equation for our circle with a center at 2, -2, and an area of 225 pi square inches. So we're going to have to use that area information to help us find the radius. Now we know area is pi r squared. So we're talking about 225 pi. That's equal to pi r squared. I'll divide both sides by pi so we can see 225 is equal to r squared. And we know that r squared has to go into our equation. So we'll get ready to plug that in. So x minus 2 quantity squared plus the y plus 2 quantity squared. And this is equal to r squared, so this is equal to 225 for our equation. Then that question number 10 here, to write the equation for the circle shown in our graph, we're going to have to identify that important information. So look at the center of this circle. Let's see here, we are 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4 up from the origin. And then we also need to count the radius. 1, 2, 3, 4, 5. It looks like we've got there. And so we plug those in then. The x plus 5 quantity squared plus the y minus 4 quantity squared equals 25 to make that equation for us. Number 11 also wants us to do the same information with a graph to write the equation for it. What I am going to have to do, though, is identify where the center of my circle is. So you're going to have to eye that up and find that spot that will be in the center. Find the spot where you can count the same radius up, down, left, and right for it in order to identify the proper center. So based on this, we can now see that the center is at 3, -1. And we also know that the radius, as we've counted it to be equal on all sides, is 4. So we use that to write the equation then. We've identified the information, so we're talking about x minus 3 squared plus a y plus 1 squared, and that equals my radius squared of 16. All right, number 12 wants us to take this equation and write the equation in standard form. Notice that we are not in that parenthesis form, so we do have to complete the square for it. I'm going to begin by writing this with my x's chunked together and my y's chunked together. Okay, so x squared plus 14x plus a little something else and then plus the y squared minus the 10y plus a little something else. And this equals, now remember that 65 that we had on the left, we're going to have to subtract that from both sides to move it on over to the right. So as we solve that, we want variables on the left and we want constants on the right. Okay, so we're going to keep on working through this with our x values. You take your b value and divide it by 2. Then we square it. So that tells me that the completion of the square is an x plus 7 quantity squared. Then for our y values, take that b value, -10, divide it by 2, and that will be squared. So we're talking about y minus 5, and that gets squared. Now remember, the other side of your equation had that -65, and it has these new values that we filled in the blank with. So the 14/2 was a 7 squared, means that we're adding 49 to both sides. And my blue value, -10/2, is that -5 squared, so I'm adding 25 to both sides. So one little bit of cleaning up with that. We got the x plus 7 squared, we got the y minus 5 squared, and we just need to do that arithmetic now on the right side. -65 plus your 49 plus the 25 puts us at 9. So here is the equation of the circle in standard form then. Using this information now, we can answer part B for the center of the circle. That's at -7, +5. And we use that same information to identify the radius. That comes from our 9. 9 is the r squared, so the radius is 3. Okay, 13. This circle here is defined by this equation. We want to identify each point that lies on the circle. So for that 13, I would probably recommend that using the graphing calculator might be one of the easiest ways to manage that. So I'm going to type in my initial equation, x minus 4 quantity squared plus y squared equals 9. And we're going to look at all 8 of these points that we are asked about to find out which ones lie on the circle. So I'll begin with the point at -5, 0. And that point is not on my red circle, so that point will not be one that I am selecting. I'll go to the right for my next point at 1, 0. Look at that. We do have a point on the circle. I can select it. Moving over to the right again, I'm talking about the point at 4, 9. This point is much too high. That's not going to be included. What about the point at 4, -9? This looks like it's much too low to be on our circle. Let's not use that. Moving to the next row, 4, 3. I've now found a point on the circle. Then I try the next one over. Let's see if 7, 0 is on there. We've hit something on the right side of the circle. This one's included. Let's move on. I wonder about the point at 4, -3. This one lies on the circle. Lastly, I'm looking at the point 13, 0. And I'll have to move my graph a little bit, but that point is not on the circle. We will not be including it as a selection. And then we have this number 14 to end with. And so lastly, the question number 14, which graph here is the best representation for the equation? So I'm going to look at this and begin by identifying the center. I know that my center here is at +3, -6. So when I look at these pictures, +3, -6, that looks like it could be my center. +3, -6 would be my center, so I don't believe that one's going to be the answer. +3, -6 could be a center, and +3, -6 could be the center again. All right, so we've narrowed our choices from 4 down to 3. I also need to take a moment and think about the radius. So if my r squared is equal to 55, then I'm going to take the square root on both sides to find out about my radius, which is 7.4. So almost 7.5. Now, some of these graphs are a little bit small, but we are going to eye them up and count our best to find out who has that radius that is just over 7. So if I'm looking here, I see 1, 2, 3, 4, 5, 6, and a little bit. So we're close, but I don't think that's quite it. This radius here looks like it's 1, 2, 3 units. That's definitely way too small for us. And if I count a radius here, let's see, 1, 2, 3, 4, 5, 6, 7, and a little bit more. Looks like we have a winner for the correct radius there. I hope that you're feeling a lot more confident now with writing the equation of a circle, graphing it, and being able to complete the square. Have a great day.